So if you remember what we did with the triangular plate and the rectangular plate case, we know the mass moment of inertia at the center of gravity individually. Like we know this one. For the rectangle, for the shape 1, we know this is the G. Right? We know this, and we also know the center of gravity for this triangle. I'm sorry, for this rectangle, which is, you can call G1, G3. For the triangle is 1/3 from the base, which is one here, another one is here. So you can call this X1, X4, X3. Now in this case, X2 is just X4 because they're all the same. They're on the same level. Right? Individually, they have their own centers of gravity. Correct? So if you divide it into 4 different shapes, you identify 4 centers of gravity. Here, 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 here. Therefore, when we apply principle of superposition to complicated objects, you have to start from the center of gravity by applying parallel axis theory. Therefore, whatever the value you put here, you can always write it like this. You always have to write it like this. I equals 1 to 4, but this one must always be Ix at the center of gravity. Gi plus Mi and Di squared. This is what we call property of superposition, because the center of a complicated object like this one here is usually not the center of individual shapes, right? That's usually not the case, which is why you always have to calculate this one by one. For instance, to find the mass moment of inertia, Ix, of this complicated shape, you had to find out what is the Ig for the shape number 1, and the shape number 2, shape 3, 4, individually. So they all have their individual shapes. And then once you've done that, you have to find out what is the individual distance. And so here, the mass you're going to use here must be individual mass. The distance, for the distance, we can quickly calculate it. Suppose this distance from here to here. Suppose this is a value b, and suppose from here to here, this is just h over 2, like this, right? And for the shape 1, please tell me what is d, the corresponding d. Here, what is M1?
We don't know M1.
So well, to tell you this length is b and the height is h over 2. And of course, suppose you have a mass density, and also suppose you have a thickness, T equals thickness. Then what will be the mass for the shape 1, which is this one here? Remember, mass is mass density times volume. So the question is, what is the product of rho times the corresponding volume in terms of B and H?
Would it be rho times T times B squared over 2?
B is correct. B is only the length, right? And the height is not B. Height is h over 2. So it should be B times h over 2, right?
Oh, that's an H. I'm sorry.
Right, so this is h over 2, h over 2.
Okay. Makes sense.
Right? So here, this part is volume and times mass. This will be the mass for the shape 1. Now, next question is, what is the distance d1 for the shape 1?
H over 4.
Correct, h over 4. Okay, so that means when it comes to finding the mass moment of inertia of complicated objects, you always have to remember the formulation is always going to be like this. You have to use parallel axis theory, and you have to include them all together, one by one. Whatever you have learned from previous examples for the mass moment of inertia at the center of gravity only constitutes part of it, which is just the first term. So you always have to use whatever we get from the mass moment of inertia at the center of gravity, which is Ig right here, Ig1. For the first, and then you put them together one by one. All right? Now, next property. Any questions?
Just clarifying.
Yes.
It's pretty much like a weighted average of the individual moments of inertia, right?
It is the, I wouldn't say weighted, I would say projected.
Okay. Okay.
Here, the weighting function, if you, there's no weighting function here. The change is the second term, which is the projection part. We can try the rectangular shape, which we did before, to quickly understand this. For the problem we considered before, we have x and y like this, right? And what was the result last Friday? What is Ix? If I tell you this is B and this is H, what's the result from last Friday?
1/12 or 1/3 BH. I don't remember offhand. I'm sorry.
Now we want to go to your notes. Angela?
Base times height cubed over 12.
Over 12?
Yeah.
So this result is for this shape, which is this one here. Ix is 1/12 of mh squared, right?
Oh, okay.
Correct?
Makes sense.
Is that right? Is that what I gave you last week? Let me be sure.
I got written down 1/3. I'm not sure.
It's not 12, 1/3. Okay? Be careful, it's 1/3.